Okay, let's go over this Unit 8 review. That's pretty much all about area. A little bit of perimeter, but pretty much area. Okay, this first problem, we have quite a bit going on. So I'm just going to kind of walk you through it a little bit. I was given a rhombus. I was asked for how many square units would enclose inside of the rhombus. So I know that means to find area. This is my formula for area of a rhombus, also area of a kite. They told me that TR was 10 units. So as soon as I knew that TR was 10, I knew that each of those would be 5. I was told that the perimeter of the rhombus is 52, and I know all 4 sides are the same, so that means all sides are 13. I had to do Pythagorean theorem to figure out this length down here, or you might have just spotted that this was a 5, 12, 13 triangle. That is one of our popular Pythagorean triples. And then once I'm ready, I know diagonal 1 is 10 and diagonal 2 is 24. And then I just multiply those and divide by 2 and get an answer of 120. So Pythagorean theorem, that does pop up quite frequently, but we had to do it in order to find this length of the diagonal. Once I knew this length, I knew that's what this one would be, and then I could come up with that whole diagonal being 24. Okay, number 2. When it says determine the number of square centimeters that will fill the space, I know that means find area, because area is on square units, square centimeters, square inches, square feet, and so I know that that's what it wanted me to do. And so I just needed to know what shape this was, and I know that this is a trapezoid. And so to find area of a trapezoid, this is the formula that we use. And our parallel sides, those are the bases, and the height is the one that connects them. And this is what you should have got.
Oh, I did my homework.
See ya. And you could have done this shape where you split it into a rectangle and a triangle, but it's just easier to just work as a trapezoid, maybe. And if it's not, if you like to split it into the rectangle and the triangle, you're welcome to do that as well. But remember, a trapezoid has one set of parallel sides, and the other 2 sides, they're not parallel. And then just remember that your bases, those are your parallel sides. Okay, let's move on. Number 3. This one was a little involved. I was given 4 points to plot. Once I plotted those points, I could tell that I had a parallelogram because these 2 sides are parallel and those 2 sides are parallel. I know that area of a parallelogram is base times height, and they already gave me the height. I know that the height is the square root of 1.8, so all I have to figure out is the base. And they tell you that BC is going to be used as the base, and so if you want to know the length of BC, then you have to use the distance formula between those 2 points. So the distance formula looks like this. It's where you subtract your x's, square it, subtract your y's, square them, add them together, giant square root over all top of that. And so to find the distance from B to C, I just focus on those 2 ordered pairs. I subtract my x's, square it, subtract my y's, square it, and you will end up with the square root of 20. And since that's my base, I put that into the B, and I already knew the height was the square root of 1.8, and then I just put that in my calculator, and then I rounded. Well, actually, this one I didn't have to round. It came out nice and pretty. It was just a pretty little 6. So this one was kind of fun because we got to use the distance formula. Smiley face. Okay, next one. This one I could see a lot of people messing up on. They want to know the height of an equilateral triangle, and it tells you that the apothem is 5, and it wants to know the height of the equilateral triangle. So I saw a lot of my students the other day saying that the height was 10, but it isn't. So let's look. So I know that the apothem is 5. That's the distance from the center to a middle of a side. And I figured out what kind of triangle I was working with by finding my central angle, 360 divided by n. That gave me 120, so I know that this angle right here is always half of what I find, so that's a 60. Across from the 60 is the x squared root of 3, across from the 30 is x, and across from the 90 is 2x. If x is 5, I know that this is 2 times 5, so this length right here is 10. So that means this length is a 10. And the reason is this is the radius because it goes from the center to a vertex. Well, this is a radius because it goes from the center to a vertex. So if this is a radius and this is a radius, then they both must be 10. And so then I can find my height by adding 10 plus 5. And the height would be 15 inches. Okay, so just because the apothem is 5 doesn't mean that the height is 10. So we actually had to work with our triangle over here that we've been using with the regular polygons. And I had to find the radius, so I knew that piece, and then I could add it to the apothem. Okay, this one, I'm just going to show it all to you, and then I'll just talk you through it. Okay, this is made up of a triangle and a square. And I had to figure out the height of my triangle. So if this whole base is 30, I know this piece is 15. So I had to do Pythagorean theorem, which is my work over here. And I found that this was a height of 8. So then when you go to find the area of the triangle, I just did the whole big triangle. The base of the whole big triangle is 30. We found the height to be 8. I divide by 2. And then the square is a 20 by 20 square. So I take 20 times 20, length times width, or you could take 20 squared, side squared. But you should get an answer of 520. So our Pythagorean theorem, it popped up again. Had to do that in order to figure out my height. Okay, moving on. Number 6, you can always pause me if you need to pause me. All right, so let me talk about my game plan here. My game plan was to find the area of the triangle and add that to the area of the rectangle. Oops, I forgot my L in rectangle. Silly me. Okay, area of a triangle, base times height over 2, area of rectangle, length times width. I know if this is 14 all the way up and down, and that piece is 7, so that must be 7. 15's all the way across, that piece is 8, so that one's a 7. And so base times height divided by 2 for my triangle is 7 times 7 divided by 2. And your rectangle is 15 by 7, so 15 times 7. And that makes an area of 129.5. Okay, but we're not done there. This problem talks about decking and how much it costs. Well, area is always in square units, so this is how much area we have. I know that it costs $4.25 per square foot. If I have 129.5 square feet, and it's $4.25 per square foot, I have to take this answer here times $4.25. And if I do that, I get my cost to be $550.38. $550.38. Okay, number 7, a little bit of effort here. The regular polygons, they always require a little bit more work from you. than some of the other shapes. Okay, since it is a regular polygon, I know this is the formula I'm going to use. I already know the perimeter is 36 because that was given to me. You just have to figure out the apothem. So if the perimeter is 36, that means every side must be 6. So that's how I knew this piece was a 3 and this piece was a 3, because the whole side's a 6. Then I did my 360 divided by n. I got 60, so then that's how I knew that this one was 30. It's always half the amount of your central angle. Across from the 30 is x, across from the 60 is x squared root of 3, and across from the 90 is 2x. Since I know x is 3, then I can put a 3 right there where that x is, and I know now that my apothem is 3 square root of 3, and that's all I need to know. So over here where my apothem was, I put in the 3 square root of 3. I know that perimeter, of course, is the 36, and I just work it out. And I gave the answer to you 2 different ways, in simplest radical form as well as rounded. And I didn't round to the nearest tenths, but if I did, it would have been 93.5. And this, of course, would be feet squared if I'm watching my units. Give you a minute to soak that in. It wasn't too bad. It's just, we have to work with the apothem and we have to make the triangle and figure out what kind of a triangle we actually have. Okay, number 18. Sorry, number 8. Number 8, I know that I'm going to find the area of my rectangle, which is going to be way too much area, so then I have to subtract my 2 circles. Okay, area of a rectangle, I take length times width, and area of a circle, I take pi times radius squared. And I'm multiplying by 2 because I have 2 circles. Okay, we're told that the diameter of the circles measures 18. So if this diameter is 18, this diameter is 18, so then that means that my length is 36. And of course, this is a diameter also, so that's how I knew that was 18. And then if your diameter is 18, your radius is half that. Your radius is 9. So my rectangle, length times width, is 36 times 18. Area of a circle, I take pi times radius squared, and I'm multiplying by 2 because there's 2 circles. And when I work that all out, this is what I get. And I accidentally rounded to the nearest hundredths, and then I saw the directions said the nearest tenth, so I changed my answer to the nearest tenth. Okay, let's move on to number 9. Number 9 is asking about perimeter. And so I had to use Pythagorean theorem in order to figure out this length right here. So I did 8 squared plus 3 squared is x squared. And I found my diagonal piece to have a length of about 8.5. And then we find perimeter by adding up all the sides. So I added 4 to 8.5 to the 3 to the 4 to the 3 to the 8.5. And that makes a total of 31. So hello, Mr. Pythagorean theorem. Had to work you again. Okay, this next one, it wanted perimeter as well. So I went ahead and I did Pythagorean theorem. I know if this whole base is 12, I know that this piece is a 6. And so I did Pythagorean theorem, but you might have recognized that this was a 6, 8, 10 triangle. And if you didn't notice that it was a 6, 8, 10, then you just go 6 squared plus 8 squared is x squared and just work out your Pythagorean theorem problem. And then perimeter, you add up all the sides, so you add your 10 to your 10 to your 12. And that makes 32 inches. Okay, this one I had to find the length of this bottom piece because area of a rectangle is length times width. And I did Pythagorean theorem, but you might have recognized that this was a 5, 12, 13 triangle. And if you did, wonderful. You don't have to go through all of this mess. And then area of a rectangle is just length times width. So 12 times 5. Fairly easy. Okay, number 12. I know that this is a parallelogram. So the formula for area of a parallelogram is base times height. I know my base is a 12. I just have to figure out the height. So this is a 30, 60, 90 triangle. Across from my 30, I label with x, x square root of 3 across from the 60, and I label with the 2x across from the 90. So I needed to solve this equation right here. When I do that, I get 4 for my x. So that means this piece is a 4, and that makes the height a 4 square root of 3. So I know my base is the 12. I know my height is the 4 square root of 3. Here's the answer in simplest radical form, and here it is rounded to the nearest tenth. These 30, 60, 90 triangles, they're not so bad. Okay, let's keep cruising. Number 13. Okay, this one is a rhombus. And area of a rhombus is diagonal 1 times diagonal 2 over 2. That's also the formula for area of a kite. Okay, I had to work with the 45, 45, 90 triangle. Across from my 45s, I labeled with x's, and across from the 90, I labeled with x square root of 2. And then I had to proceed to solve this equation right here. And so you can see my work. I got the x by itself by dividing both sides by square root of 2. That just went away. Shoop. And then I can't leave the square root in the denominator, so I went ahead and I rationalized my denominator by multiplying by square root of 2 over square root of 2. And I finally get 3 square root of 2 for my x. Well, that means that that's what this piece is, and that's what this piece is. And of course, somewhere along the way, you might have just put this in your calculator and got a decimal instead of keeping it in radical form. And if you did that, that's okay. Okay, so then diagonal 1 would be one of these diagonals, it doesn't matter. 3 square root of 2 plus 3 square root of 2 is 6 square root of 2. And of course, likewise, the other's just the same. 3 square root of 2 plus 3 square root of 2 is 6 square root of 2. And then I just multiply my diagonals and divide by 2. And so if you didn't keep this in radical form like I did, if you just worked with decimals, then you should end up with the same answer as I did. Okay, number 14. I figured out what my angle was here by taking 360 and dividing by the number of sides. If the central angle is 90, I know this one's half that, so this is 45. Across from the 45s are the x's, and across from the 90 is x square root of 2. I know that my apothem is 7, and remember the apothem is from the center of the polygon to the middle of a side. And so if this x is 7, then this x would be 7. And so our radius would be 7 square root of 2. And remember, the radius is the distance from the center to a vertex. The apothem is from the center to the middle of a side. Okay, 15. More regular polygons. Here we go. Okay, so I used my 360 over n. I found that my central angle is 60, so that's how I knew this one was 30. Across from the 30 was x, across from the 60, x square root of 3, across from the 90, 2x. They gave us that the apothem was 5 square root of 3. So I set x square root of 3 equal to 5 square root of 3, and I solved that equation over here and got x to be 5. So if x is 5, the radius is 2 times 5, so the radius is 10. I know if this little piece is 5, this little piece is 5, so that means every side is 10. So 10, 10, 10, 10, 10, 10. So the perimeter would be 60. And then I find my area by doing 1/2 the apothem times the perimeter. And here it is in simplest radical form, and here it is rounded to the nearest tenth. Okay, number 16. It says a bicycle wheel travels 72 inches in 1 revolution. So your bicycle wheel is going choo, 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 choo. And so it says that it travels 72 inches in this 1 revolution. So this distance that your tire travels in 1 revolution, is that circumference or is that area? It's circumference. So I know my circumference is 72. Then I just need to know a formula for circumference. I can either use 2 pi r or I can use pi d. Since I know the circumference is 72, I put 72 where the c is. And then it wants to know what the diameter is. So to solve for d, I just divide both sides by pi, and I get 22.9. Okay, we're almost there. Last page. Okay. This picture is made up of a triangle and half of a circle. So I'm going to find the area of the triangle. I'm going to add it to my half circle. I wrote down the formulas for area of a triangle and half of a circle. I did go ahead and do Pythagorean theorem to figure out the height of my triangle. And so you see that work over here. And I know that if this is a 10, then the radius of my circle is 5. And this is what I get. Okay, number 18. You might have done this one differently than I did, but I'm just going to show you my game plan to begin with. I decided to turn it into an entire rectangle, which would be too much, and so then I subtract the triangle that's missing. But you wouldn't have to do it that way. So I knew if this whole length was an 8 and that piece was a 3, then this piece would have to be a 5. Then I did Pythagorean theorem to figure out that bottom part right there. So here's my work for Pythagorean theorem. But you might have realized that it was a 5, 12, 13 triangle. So area of a rectangle is length times width. I know the length is all the way from here to here, so the length is 16, and the width is 8. And my triangle, the base is 12, and the height is 5, and area of a triangle is base times height divided by 2. And you should get an answer of 98. And like I said, you might have done this differently than I did. This is just how I chose to work it. Okay, number 19. I had a game plan of finding the area of the trapezoid, which is going to be too much area, so I'd have to subtract the area of the circle. Well, I know the bases of my trapezoid, but the problem is I didn't know the height. I also don't know the radius of the circle, but I know if I can find the height of the trapezoid, that's also the diameter of the circle, and if I know the diameter of the circle, I can find its radius. So I drew in these segments. I know all the way across here was 22, and I knew from here to here it was a 6. So I take 22 minus 6, and I get 16. And if each of those are the same, then each of those are 8. So then I just did Pythagorean theorem to figure out my x. And so here you see my Pythagorean theorem work. And so I found the height of my trapezoid to be 15, and that would also be the diameter of the circle. So here's my continued work over here. This is the formula for area of a trapezoid. This is the formula for area of a circle. And here I am plugging it all in. And I get an answer of 33.3. Okay, and the last one. My game plan was to find the area of the circle. That was going to be too much area. Find the area of the hexagon and subtract the 2. Okay, so I know the radius of the 12. That was given to me right away. So that part was easy. It's just I had to work on my hexagon because I needed to know the apothem and I needed to know the perimeter. So I'm just going to let you look at this. I did my 360 over in. That gave me my central angle. And once I knew the central angle was 60, I knew this was half that. I knew this one would be a 30. And then I just did all my labeling. More of the same. I had to solve the equation 2x equals 12, which gave me x was 6. Once I know x is 6, it's all downhill from there, because that makes this piece 6, this piece 6, so every side is a 12. That's how I found my perimeter. And then the apothem is x square root of 3, and if x is 6, the apothem is 6 square root of 3. And this time I didn't actually give you the answer in simplest radical form, so I'm sorry about that. But I went ahead and I gave it to you as a decimal, 78.3. And that's that. We're done. Smiley face. Good luck on your test. I hope you do excellent.